Okay, this is 1.7 part 1. We're going to talk about solving inequalities. So inequalities are greater than, less than, greater than or equal to, less than or equal to. The most important part on this page is when we are multiplying each side of an inequality by the same negative quantity, it reverses the direction of the inequality. So if we multiply or divide by a negative number, we have to flip the sign of the inequality. So we reverse the sign. So let's look at example 1. We're solving the inequality and sketching the solution set. So just like when we solve equations, we want to get our variables on one side and the constant on the other. So I'm going to move my variables to the left side. I'm going to subtract 9x, combine my like terms. So I have negative 6x is less than 4. Then in the next step, I'm going to divide by negative 6. Since I'm dividing by a negative, I have to flip my inequality. So because it's a less than, I'm now going to change it to be a greater than. So we have to flip it. Whenever you divide or multiply by a negative number, you have to flip your inequality. So the negative 6's cancel. We have x is greater than 4 over negative 6, which simplifies to 2 over negative 3, or negative 2 over 3. So next we're going to graph or sketch the solution set. So we're going to put it on a graph. So I'm going to draw my number line. Negative 2/3 is in between 0 and negative 1. So it's about here. We'll call this negative 2/3. Because it's just a greater than sign, we put an open circle at that point. And then when your x comes first, the inequality points in the direction that, like, if this was a little arrow, it would point to the right. So we go here. You can also tell which way your arrow is going to point by plugging in a number. So, like, we could plug in a number 0. Say 0 is greater than negative 2 over 3. This is true, so 0 is going to be highlighted on our line, so it's going to go in the direction of 0. So if you want, you could always plug in a number, but when your x comes first, the inequality is kind of like an arrow and points in that direction. Also, just to make note, if it's greater than or less than, we have an open circle. If it's greater than or equal to or less than or equal to, we put a closed circle at that dot. At the point. So this one was just greater than, so it's an open circle. Let's look at number 2. So here we have a compound inequality. Notice that we have a less than or equal to and another less than sign there with our x in the middle. So we want to get our x all alone in the middle. You can either split it up and work with it as 2 inequalities. So you would treat this as 1 and then this as the other inequality, and you can do it as 2 separate equations, or you can just work with it together. But when you're isolating your variable, you just have to do like whatever it is to cancel out that number to both sides. So here I want to get x all by itself, so I'm going to add 2. So I also have to add it to the right side of my inequality and the left side. So it's going to cancel out there. Don't forget to add it to both sides. So here we have 6 is less than or equal to 3x, which is less than 15. Last step is we're going to divide by 3. So here, 2 is less than or equal to x, which is less than 5. Whenever you have a compound inequality, you always want your smaller number to be on the left. So this is the smaller one. 2 is smaller than 5, so we're good there. If it wasn't smaller, then you would have to just flip your inequality, but just make sure you keep the signs in the same order that they are. So like if we were to flip it, the signs get flipped with it. So here our smaller number is on the left, so we are good. We don't have to flip anything. We can just put it on our number line now. So I have 2 on my number line. 5 is going to go to the right of 2 because it's a bigger number. And we have less than or equal to, so that's going to be a closed circle at 2. We have a less than sign at 5, so it's going to be an open circle at 5. And since x is in between 2 and 5, we're going to connect our 2 points here. We're going to draw our line in between 2 and 5. So also you can just plug in a number. So a number in between 2 and 5 would be like 3. 3 would be about there. You could plug in a number. 2 is less than or equal to 3. That's true. And 3 is less than 5. Yes, so we would color in between our 2 lines or 2 points. So let's do some more practice on the next page. We are solving and expressing our solution in interval notation and graphing it. So looking at number 1, your example in the notes is missing the x, so it should be 2x is greater than or equal to 8. So here we want to solve for x, so I'm going to divide both sides by 2. X is greater than or equal to 4. So this is solved. That would be part of our answer. X is greater than or equal to 4. We isolated our variable, so now let's put it on the number line. So our key point is going to be at 4. I'm going to have a closed circle at 4 since it is greater than or equal to. And since it's greater than or equal to and x comes first, it's going to point in that right direction. So we're going in the direction to the right. You can also test yourself. 5 is on our number line. So we could say 5 is greater than or equal to 4, which is true. So our line's going to go in the direction of 5. For interval notation, part of this question says express your solution in interval notation. That we can come up with once we have our number line. So I'm going to use my key number from the number line, so 4. And interval notation is either going to go to infinity or it's going to start with negative infinity. Your interval notation always goes from smaller to larger. So 4 and 4 gets a bracket because it's a closed circle. And my line goes forever to the right direction, which goes to infinity. So it would be 4 to infinity, and infinity always gets a parentheses. So for interval notation, some important things to remember. It always goes from smallest to largest. So if we have a negative infinity, or if our line is pointing to the left, it's going in the direction of negative infinity. So negative infinity would always start first if it goes in the left direction. If it's pointing in the right direction, it goes to infinity. And the infinities always get parentheses. If we have a closed circle, that would get brackets. And then if we have an open circle, that point gets parentheses because an open circle is not equal to, so it's not including that point. So we just put parentheses and not brackets. But here 4 had a greater than or equal to. It was a closed circle, so closed circle means that we put a bracket. All right, let's look at number 2. So we want to isolate our variable. Let's move everything else to the other side. So first thing we're going to do is move 11. So I'm going to subtract 11. We have 3x is less than negative 6. Next, we're going to divide by 3. So here we're not dividing by a negative, so we don't have to flip our sign. It stays exactly the way it is because we're dividing by positive 3. So x is less than negative 2. I'm going to put this on my number line. So I'm going to put my key point at negative 2. When x comes first, whatever your inequality sign is, that's the direction that it points in. So we're going to point in the left direction here, but you can also test a number like negative 3 would be to the left. And you could say negative 3 is less than negative 2. That is true. So we would go in the direction of negative 3. And since this is just a less than sign, we put an open circle there. Now, when we write our answer in interval notation, we always start going from left to right. So our graph goes in the direction of negative infinity. So negative infinity is smaller than negative 2. So negative infinity would go first. Infinity or negative infinity always gets parentheses. So we'd put parentheses, negative infinity. And then next we put our key number. So it goes to negative 2. Since it's an open circle, we put a parentheses and not a bracket. So this would be interval notation. So part of our answer is having our inequality with that x all by itself. Part of the answer is having your number line drawn out. And then the other part of our answer is interval notation. So writing the interval of our answer. Let's look at number 3. So here we want to isolate our variable. So I'm going to subtract 5 to move it to the other side. So we get negative 4 is less than negative 2x. Next, we want to divide by negative 2. Since we're dividing by a negative number, we have to flip our sign. So negative 4 divided by negative 2 would be positive 2. And instead of less than, we change it to greater than. Because we divided by a negative number, we have to flip our sign. So we have 2 is greater than x. So I'm going to draw my number line. I'm going to put my key point 2. It's going to be an open circle at 2 because it's just a greater than sign. Now here x doesn't come first, so we have to be careful in which direction that we draw our line. We can pick a number, so 2 is greater than x. Let's say x is 1. 2 is greater than 1. That is true. So we know that our line has to go in the direction of 1, which would be to the left. Remember, your number line always goes like in number order. So because 1 is smaller than 2, it goes to the left. Now with interval notation, our line goes to negative infinity, which is smaller than 2. So I'm going to put parentheses, negative infinity. My line ends at my key point, which is 2. It's just a greater than sign, so it gets a parentheses. So that's part of our answer. This is part of our answer. Our number line is part of our answer, and interval notation. Let's do number 4. So again, here we want to solve for x. We want to isolate our variable. So I'm going to distribute the 2. So I have 14x minus 6 is less than or equal to 12x plus 16. Then I'm going to subtract 12x to move it to the other side. So I always like it when x comes first, because that way we can just draw in the direction of our arrow. So I'm going to move the 12x to the left. And that means I'm going to move my constants to the right. So I'm going to add 6 and move it to the right. So 14 minus 12x would be 2x is less than or equal to 16 plus 6 would be 22. Next, we want to divide by 2. So x is less than or equal to 11. So I'm going to put that on my number line. Since it is less than or equal to, we're going to put a closed circle. That equal to means that we close in the circle. And then we see that our arrow, since x is coming first, our arrow points in the left direction. It's the same arrow as this one. Or if you wanted to, you can plug in numbers. So we could plug in 10. If you wanted to, you could plug in 12. So we would say 10 is less than 11. So that is true. So I'm going to highlight in the direction of 10. If you wanted to, you could say 12 is less than or equal to 11, which is not true. So I'm not going to color in the direction of 12. So you can always just plug in a number to check and see which way you need to color on your number line. Next, we want to write our interval notation. So we're pointing in the direction of negative infinity to the left. Positive infinity would be to the right. So since we're going to negative infinity, we start with negative infinity. And then our graph ends at 11. Since 11 was a closed circle, and because we had less than or equal to because it's equal to, we put a bracket. So less than or equal to, or greater than or equal to gets brackets. If it's just less than or just greater than, that gets parentheses. All right, next let's look at 5. So here we have a compound inequality. We've got two equations or two inequalities in one. So just be careful, whatever we move to one side, you have to do it to the other side too. So I'm going to add 4 because we want to isolate our x. So I'm also going to add it to the right side of my inequality and add it to the left side of the inequality. So we get 9 is less than or equal to 3x, which is less than or equal to 18. Again, we want to isolate our variable in the middle, so I'm going to divide everything by 3. So 3 is less than or equal to x, which is less than or equal to 6. So when we have a compound inequality, we always want to start with the smaller number. So here we start with the smaller number. So we're good. We can put it on our number line. So I'm going to have 3 and 6. Now, 3 is less than or equal to x, which is less than or equal to 6. So we could pick a number in between, like 4. 3 would be less than or equal to 4, which is true. And 4 is less than or equal to 6, which is also true. So we're going to highlight in the direction of 4. Because these are both less than or equal to, we put a closed circle at 3 and 6. Now we can do our interval notation. So our graph here doesn't point to negative infinity or positive infinity. It only goes from 3 to 6. So our interval notation is going to go from 3 to 6. And they both get brackets because they both have that less than or equal to. So the equal to means that they're going to get brackets. So our interval notation is part of our answer, our number line is part of our answer, and our interval here, or inequality, is part of our answer. We have 2 more on the last page, 2 more compound inequalities. So with number 6, I want to isolate my variable in the middle. So I'm going to add 4. So we get negative 4 is less than or equal to 5x, which is less than or equal to 9. Next, I'm going to divide everything by 5. So negative 4 over 5 is less than or equal to x, which is less than or equal to 9 over 5. We know that negative 4 over 5 is smaller than 9 over 5 because it's negative. We like it when the smaller number is on the left, so let's go ahead and graph it. So we have negative 4 over 5 and 9 over 5. We can pick a number in the middle and test it to see if it works, to see if we're going to end up highlighting in the middle. So we could pick 0 because 0 is going to be in between a negative number and a positive number. So negative 4 over 5 is less than 0. So that is true. And 0 would be less than 9 over 5. That is also true. So we're going to highlight in the direction of 0. And then also add our key points at negative 4 over 5. Since it's less than or equal to, we're going to put a closed circle there. And at 9 over 5, since it's less than or equal to, we're going to put a closed circle there. Lastly, we're going to do our interval notation. So because they're both closed circles, we're going to put our brackets, and our graph, or our highlighted part of our graph, goes from negative 4 over 5 to 9 over 5. So we have our interval notation, our number line, and our inequality. Last example, let's do number 7. We want to isolate our variable in the middle. So I'm going to subtract 7 on both sides. Negative 3 minus 7 would be negative 10, which is less than or equal to 3x, which is less than or equal to, here, we have a fraction minus a whole number, 1/2 minus 7. So if we're going to subtract a fraction and a whole number, we need a common denominator. So I'm going to make it 7 over 1, and then change it to be 14 over 2. 1 minus 14 here would be negative 13 over 2. Lastly, we're going to divide by 3. So we would just leave this as 10 over 3 is less than or equal to x, which is less than or equal to, here we have a fraction in a fraction. Whenever we have a fraction in a fraction, we keep, change, flip. Keep the numerators, we keep the negative 13 over 2. We're going to change to multiplication and flip our denominator. So since our denominator is just the whole number 3, we're going to flip it to be 1 over 3. Now when we multiply fractions, we multiply straight across. So this would be negative 13 over 6. Now our smaller number is on the left, which is what we want, so we can go ahead and put it on our number line. We have negative 10 over 3 and negative 13 over 6. If you're not sure which number is smaller, you can always divide your fractions to see about approximately what the number is. We have negative 10 divided by 3 would be, 3 goes into 10 about 3 times, so we could say like negative 3 point something. For the other one, we would divide negative 13 by 6. 6 goes into negative 13 about 2 times. This would be negative 2 point something. So negative 3 is smaller than negative 2 because it's a bigger negative. So it would be a smaller number. Next, we can put our points. So because it's less than or equal to and less than or equal to, we have 2 closed circles. And x is going to be in between these 2 values. Lastly, we want to do our interval notation. Because they are closed circles, we're going to put brackets. And then we just put our 2 key numbers in the brackets. So negative 10 over 3, comma, negative 13 over 6. So we have our interval notation, our number line, and our inequality. So those are the 3 parts to our answer. So what we did today was just linear inequalities. So notice how we didn't have any x squared or any higher degree variables. We just had ones with x's. Your web assign is going to be 1.7 part 1 and 2. So part 2, we're going to have like x squareds, higher inequalities. Part 1 was just x's. So web assign will have both. It'll be due Wednesday. So if you have questions about this, you can ask me tomorrow in class. But half of the web assign will be from what we did today, part 1. The other half will be part 2. So you can get the part 1 questions done, and then that way you only have to work on part 2 tomorrow. Also, the completed notes are due at the end of class, so make sure you turn them in.